Good morning, everyone. I'll be starting my next session regarding the topic digital image processing. First, I'll share my screen. Okay. Before moving into the digital image processing, we have to know what is an image. And then you have to know what is an image acquisition. And then what is an point operation. And what are the various operators that we are going to use. So, as well as we are just going to discuss about the edge detection. So, this I'm not going to discuss all this in this lecture. I'm just going to discuss about what is an image and what is an image acquisition, and I can just give an introduction about what is an point operations. Okay, initially, what is an image? So how everyone know what is an image? It can be a two-dimensional image or it can be a three-dimensional image. But I'm not going to convert that into any kind of the digital format. Okay, that is the difference between an image as well as a digital image. If I'm taking an image, I'm going to use that image as it is. That is a normal image. If I'm taking that image, if I'm converting into any kind of the digital format, like I'm going to compress it, or else I'm going to convert into the format according to my convenience, or I'm going to crop it. That all comes under the category of digital image processing. Now here I'm just going to discuss about an image. So just I'm going to take out an image and I'm going to use it as it is. That is known as the basic image. So if you take an image, it can be a two-dimensional function. I mean, I'm going to take a 2D image. So f of x comma y. What does the f of x comma y represent? F is a function and x comma y means it is an coordinate. So the function, I mean f of a. A represents amplitude. What are the amplitudes I'm using here? X and y. So the function is depending upon the coordinate. So that's what it was mentioned here. X and y are the amplitudes and f represent the function. So what are the things? If you take out the image elements will be there. So for example, if you take an image, if there is an apple is available in image, so the apple is an image element. And then we'll be using the pixels. So if I'm having the two-dimensional image or three-dimensional image, it will be containing the rows and the columns. So that's what it was given. So image can be defined by the two-dimensional array, specifically arranged in the rows as well as the columns. So the most important point is that the image, I'm going to use it as it is without converting into the any kind of the format. That is a basic image. So if you take an image, if it is a two-dimensional image, it will be represented as f of x comma y. So f is a function and x comma y means it represents that the function that I'm going to use that will be depending upon the coordinates. And more importantly, if you take an image, what are the things that will be available? So corner diagonals will be available, corner pixels will be available, center pixels will be available. Through the center pixel only, we'll be operating with the various operators like edge detection. So there are three types of the images that we are going to discuss. One is a binary image, and second one will be the grayscale image, and third one will be the colored image. So if we take a binary image, maximum it will be containing of 1-bit image. It will be of black and white. So for example, what is a OCR? What is OCR? Everyone know what is an OCR. So if I'm taking a PDF, if I'm going to search something, I have to get that word which I'm searching. That is OCR. So if I'm not using OCR, if I'm having the 50 pages of PDF, so it will be very difficult to identify my schedule. For that only, I'm going to use an OCR. So nowadays, whatever the application that I'm going to use, everything is filled with OCR. For example, if I'm taking a PDF, I'm going to use a application for PDF will be a Adobe or WPS. Like that, everything is filled with the OCR. The reason for using the OCR will be that to identify the schedule of mine, or to identify my name, or to identify my friend's name, or to identify my colleague's name. This is the main reason why we are using the OCR. So what is the advantages of the binary image? So first, I already said by using the digital camera, we'll be applying the OCR, as well as threshold can be applied. So as well as it can be converted into the grayscale image. So next topic is a grayscale image. What is grayscale image? I will say later. Next is a low storage. I already said if you use a binary image, it won't exceed more than 1 pixel. So as well as what is a simple processing? We won't be using many complex algorithms for this. We'll be using the simple algorithms to process it. What is the disadvantage? In case if I want to improve the clarity of it, I cannot do it. Because if I improve the clarity, that will be increasing the pixel size. So it will be of limited number of the pixel. So only the limited number of the application will be used. And I cannot improve the pixel value. So I cannot extend to 3D. That's what I said, that I can just use a 2D and f is a function and x comma y will be the amplitudes that will be depending upon the coordinates. So these are the advantages as well as the disadvantages. So what is the threshold? What is a threshold? So binary images that are generated by using a threshold operations. What is a threshold operation? So threshold means, first I'll be saying that in case if I'm taking out any kind of the image, so there will be a foreground as well as there will be a background. So I'll be applying the threshold for the foreground. So in that case, the foreground will be having the higher value than the background. So in case if I'm applying the threshold to the background, so the background image will be highlighted than the foreground. So that's what it was represented as a zeros and ones. If you take a figure, so if you take out a binary image, so again I'm repeating what is the threshold. So if you take a binary image, it will be of zeros and ones. So foreground means 1. So the object so for example, object. I'm an object and background will be the wall. So my foreground image, my image will be having the higher value than the background. So my image will be focused more. So only in the slide it was given as 1 and background is 0. So I will be highlighted more. Now you can look at my image. My image is highlighted more than the background. So threshold value will be applied more compared to the background. So my image will be given the threshold as 1 and background will be given as 0. So this is the exactly what is the meaning of the foreground. This is the exact meaning of threshold. So what is a grayscale image? So to improve the clarity or for medical purpose, I'll be using the grayscale image. So, but why mainly we won't be preferring the grayscale? So if you take out apple, what is the color of the apple? Red color. But it affects its originality. So most probably, what we'll be using is that we won't be preferring the grayscale image. So only for the medical purposes, we'll be using the grayscale. So what we'll be doing is that instead of using a 8-bit, we'll be using a 12-bit. So best examples can be for this will be the X-rays. Okay. So because we cannot use a colored image or binary image for the X-rays. Always for the medical diagnosis or for the medical purposes, we'll be using a grayscale images. And next is the colored images. So colored image means this is a best example for the colored image. So I'm going to use red color, blue color, as well as the green color. So it's understood that I'm going to use the RGB. So RGB is segregated equally. So 8-bit, 16-bit, as well as the 24-bit. That is known as the RGB colors. So 8-bit, and if you are using a 8-bit, so best example is that this is a bit size. I'm going to use a 8-bit and whatever the input I'm going to take, that should fall between 0 to 7. That's what 8-bit. So in this particular thing, the input I'm going to take, it was segregated between the 8 bits. So red color, I'm taking a 3-bit and green color, I'm going to take 3-bit and blue color, I'm going to take 2-bit. So how I'm going to segregate it? So depending upon soothing to the eyes, I have to segregate it. Instead of red color, I can apply 3-bit for blue color as well. But the thing is that depending upon the soothing to the eyes, I can segregate that into the 8-bit color. So next, I can move into the 16-bit. Same thing only. It is a high color format. So I have to use a RGB color. So I already said there are 5 bits for red and 6 bits for green and 5 bits for the blue. So one additional bit is added in a green because by compared to the all the three colors, green color is soothing to eyes. So for example, same example I'm taking. I'm taking an example as apple. So apple is of red color. So automatically all the 16 bits will be applied to red and green and blue will be avoided this. This can be the best example. And if it is a 24 bit, so whatever the input I'm going to take, that will be equally segregated among all the RGB. So R will be for 8 bit and green will be for 8 bit and blue for the 8 bit. So all the 24 bit that will be equally segregated. So these are the three types of the images that we discussed. So if it is a binary image, I already said that we'll be using the 1 bit. So g of x comma y. So g is a function that I'm going to use. X comma y is an coordinates. The function that will be depending upon the coordinate. And then next is a grayscale image. I already said g of x comma y. The c represents a bit I am going to use. It is of 8 bit, but 8 bit is not sufficient to represent the medical diagnosis. So I'm converting that into the 8 bit to 12 bit because it affects the originality of the input that I'm going to take. Instead of 8 bit, I'm just going to take a 12 bit or 16 bit. So for the medical diagnosis, if I'm going into the 16 bit, I can avoid the grayscale and I can prefer the colored images. And then last one is a colored image. So G of R represent the red, G represent the green, B represent the blue. So that is known as the RGB and it was equally segregated as 888 bit. So totally 24 bits I'm going to use it. So next we can discuss about what is image processing. In this video, I'll be just discussing about what is image processing and what are the basics of the image processing. I already said what is an image. What is an image? I'm just going to take out an image. I'm not going to convert into the any kind of the digital format. That is known as an image. Now we are moving into the image processing. Why we are using the image processing? We convert into the any kind of the digital format. For that, I'm going to use a image processing. The reason is that I have to improve the clarity. That can be one reason. Or else I have to crop. If I'm taking a multiple one image, in that image, my friend is not looking good, I'm looking good. So I have to crop it. For that, I have to crop only myself and I have to discard my friend. For that, I need a digital image processing. And then I have to show the image. I mean, I have to show my project in the graphical representation. So I might have took some existing system and I proposed it. So I have to show the comparison. For that, I need a graphical representation. For that, I need a digital image processing. For example, I need to upload my video in any one of the application, but my video is lengthier. So I have to compress it, sorry. For that, I need some image processing. So these are the things that comes under the image processing. So that's what it was mentioned here. Image processing is a method. I'm going to convert that into the digital format depending upon my convenience. I mean, depending upon some useful information, depending upon my needs, I'm going to convert it. So there are many purposes of image processing. First one is the visualization. Second is the image sharpening. And third is the image retrieval. Fourth is the measurement of the pattern. And fifth one is the image recognition. So these are the topics that we can discuss in the next lecture. As of now, in this lecture, we discussed about what is image. What are the different types of the image we discussed. And then we just discussed about the definition of the image processing. In the next video, we can discuss about what are the purpose of the image processing. Now I'll be stop sharing it.